Mute myself.
Okay, thank you. Okay, folks, it's 10 o'clock. I see there are people standing up in the back. If you could all please sit down and we can get started. Okay, thank you all. If someone in the back could close the door, that would cut down on the noise from the hallway, please.
5:05.
Okay, very good. So I'm Andy Malice. I'm chairing this session, which is the joint PALS, MPLS, and DetNet session. And I'll be talking more about what we're doing here. I'm being ably assisted today by Tariq Saad, who's sitting up at the front table. He's able to take over if anything bad happens to my internet connection here at home. Also, I'm assisted by Dave Sinacrope. Dave is taking the minutes for today. And in fact, if any of you would like to help take minutes, that would be greatly appreciated. All you have to do is go to the IETF agenda page, and in the line for PALS, one of the icons in the right says Notes for Note Taker. If you just click on that, that brings up the note-taking tool, and you'll notice that Dave has already populated that with today's agenda, and he's just adding notes after each item in the agenda as they come up in the meeting, and you're all free to take notes there as well. It's a cooperative effort, and I thank everybody who helps on that. Oh, yes, and of course, this session is being recorded, as are all IETF sessions. I'm sure you've all seen the note well already, so I don't have to spend very much time on it. It's the second day of the IETF, and it hasn't changed since the previous IETF meetings either. Here are some meeting tips, just because this is a hybrid meeting. So we have some notes here for the in-person participants. For those of you who are sitting in the room, please make sure that you sign into this session using Meet Echo Lite. And if you take a look at the little diagram on the slide, it shows you the icons that are to the right of the PALS session. What you want to do is you want to click on the Meet Echo Lite, which is an icon that looks like a phone, and that will bring you up, and you need to use that in order to be able to get into the queue. You will not be recognized if you just stand at the microphone. You actually have to get into the queue so I can see and manage the queue from here at home. And I would also like to note that I have the ability to give you if you're a speaker, I have the ability to give you control of the slides, and you can use that application to take control of the slides to move them back and forth. So if you're speaking and you would like control, just ask, and I'll be able to hand off control to you. Also, I would like to point out that for those of you who are in the room, please keep your masks on. In fact, not just please, it's required that you keep your masks on. And it says on the slide, unless actively speaking. Well, I've been told that with the microphones that we have here at the hotel, they actually pick you up very well, even if you're masked, as long as you speak right into the microphone. So you'll probably find that you do not need to unmask when you speak at the mic as well. For those of you who are at home like I am, please make sure your audio and video are off unless you are actively chairing, as I am, or you're doing a presentation. And please use a headset if you have it. Although I did a mic check with Christian earlier, I was able to hear Christian just fine. So sure, in good shape, Christian. Next, so the purpose of this meeting, this is a joint session for the PALS, MPLS, and DetNet working groups. It's focused on the work of the joint open design team for the MPLS network action indicators and MPLS ancillary data. This is work that's been going on for just about a year now, I think. And it's been extremely active. And while all of the active activity happens by email on the MPLS email list, we've been doing joint sessions for PALS, MPLS, and DetNet while we're actually at the IETF meetings. So the overview of today's agenda is we have one item actually for the PALS working group, because PALS, this is the only meeting for PALS, and we have one item of work for PALS, which is private line emulation and signaling. Then we're going to have Tariq give us an open design team report to give us the status of where the work currently stands in the open design team. Then we're going to have a bunch of drafts for the joint design team on MNAI and MAD requirements, MNA headers, the post-stack header extension, and special purpose label for forwarding actions. Note that the open design team work is continuing, and it's not completed, and open calls will continue post IETF 114. All of those calls are announced on the MPLS email list. So if you want to participate, you really need to be on the MPLS email list. So this is the more detailed agenda. I'm not going to go into this in great detail because it's available online. It's also available in the note taker tool. So if you just open up to the note taker page, you'll be able to see this as well. So I'm not going to keep this open right here. We do have some online resources that are helpful, both today and ongoing. Here's the pointer to today's agenda. The note-taking tool, known alternatively as Etherpad, Code IMD, and HedgeDoc. It's that URL right there. That's the same URL you get if you go to it from the IETF agenda page. We're on Jabber as well. The Jabber is integrated with MeetEcho. So if you use the MeetEcho note window, that's exactly the same as having your Jabber application open. And we should note that this is the last meeting in which we will be using Jabber. And we're transitioning to a new tool called Zulip, which will be taking Jabber's place at IETF 115. So you should download the Zulip app for your phones and get acquainted with Zulip for the next IETF meeting. There's a wiki for the MPLS Open Design team. It's at that URL right there. And the wiki is where we announce all the agendas for the Open Design team calls. All the ongoing work is documented there. So if you want to participate, you should be keeping track of the contents of the wiki. And finally, while we're here in the room in the meeting, if you have any issues with MeetEcho, the meeting audio, the thermostats in the room, anything like that, send an email to support@ietf.org. They are keeping on top of that in real time, and they will help you out. And finally, there's also a MeetEcho technician who is monitoring the session. So if there are any MeetEcho issues that come up, we can get right in touch with the MeetEcho guys as well. And that's my final slide. So I'm going to close this deck and move on to Christian. Let me open that deck right there. Wait 1 second. Okay, and Christian, would you like me to move the slides, or would you like me to hand it off to you?
You can, if you can move the slides, that would be great.
Okay, very good. I'm just going to turn off my audio and video. And I'll be handing that over to you.
Okay, thanks, Andy. Thanks, everybody. Appreciate the time. It's an honor to have the first slot in this session. I would like to introduce to the PALS group the concept of private line emulation. It has been, I presented that already at IETF 108 back then at the BEST working group. And my purpose here would be to introduce you to the concept as well as give an update on the progress we made through the last couple, actually 1.5 years roughly. We can go to the next slide. Some of you may wonder why such a PALS-ish draft and a very TDM-centric draft. And there's something happening at the lower layer of the transport. And what is actually happening is that packet switching through the innovation in silicon is becoming the most cost-effective way to switch information at the electrical level. what also is happening is that DWDM and coherent transmission technology is moving in the form of pluggables into routers. And that kind of begs the question, does it make sense? And this is really at the lower transport level. It's not at the, I guess, routing control plane and service level, right? It's more on the more boring side of the house of the network. Do we really need a TDM switching layer? And predominantly that is today OTN. Or can they actually get rid of it and really let everything be packet switched or routed? And when we do that, of course, that begs the question as a follow-up: what do we do with our TDM switched services, or also known as private lines? And if we go to the next slide. A lot of things can be done with pseudo wires, right? And Ethernet pseudo wires and EVPN VPWS is doing a great job, right? The first draft part of this session is, called, PLE, or private line emulation, and is about the data plane. And it is addressing the gap that we have, that we cannot act at the bit level and be more transparent. Maybe because I want to be completely transparent for Ethernet to also support synchronous Ethernet for some special cases, or maybe I want to carry fiber channel and non-Ethernet technology. And this draft is somewhat taking what has been done in the past with RFC 4553 and for structure agnostic transport over packet, and is adopting, or let's say widening the scope to higher speed interfaces like 10 gig, 100 gig fiber channel of various rates, or even OTN or SONET SDH. Again, the underlay is MPLS, but also these days, SRv6 is a suitable underlay. The second draft I want to put your attention to is essentially adding the signaling pieces into the mix. And here, because nowadays, EVPN and EVPN VPWS is a more modern way of signaling pseudo wires. The idea is to have extensions to signal those TDM or these interface specific attributes. Next slide. Now, from a data plane perspective, it's really, a evolution of what has been done with SATOP, right? And what we are defining is three encapsulation types, which are largely agnostic to any kind of, information that's in the signal. But due to the, let's say, to a more optimized implementation for carrying ODU or carrying very high capacity 200 gig or 400 gig interfaces, we have defined some alignment where in the OTN case, we do a ODU K-frame alignment. And for the 200 gig and 400 gig, we're aligning with the 1028-bit blocks that have been defined for those Ethernet technologies. For the rest, the proposal is really to keep things the way they are, right? We have an RTP header with sequencing and RTP timestamps. We have a control word with L and R bit. So pretty much, kind of what we have done before, but essentially broadening the scope of SATOP, which really was focused around T1s, E1s, and the likes. Next slide. On the control plane side, we are taking with the second draft, let's say, what has been done in the past, and again, expanding the scope and adding a few bits and pieces in terms of TLVs to signal the specifics of those new interface types that are now being emulated. But to a large extent, I would say the approach is identical, and what we're proposing is essentially to adopt BGP instead of LDP. Next slide. So much for the introduction. As I said, I presented already the IETF 108. Since then, we had quite a bit of progress, even though I have to say that the technology may not be in fashion, right? But we have, strong interest from operators like Verizon, Deutsche Telekom, and also Sienna and Xilinx have joined us. And through that and various feedback we got from the folks mentioned here, we added quite a few of changes in the past, and I'm not going through one by one, but essentially some of the editorial changes as well as we got some agreement on what a default payload size could be and things of that nature. Next slide. We also got some more recent feedback. Again, thank you for everybody who's providing input. And more recently, we added the 1028-bit block alignment for supporting very high capacity 200 gig and 400 gig. This is probably a little bit more futuristic, but as networks may be built based on 800 gig and maybe 1.6 terabit Ethernet interfaces, this is something that will be asked by the market as well. And last but not least, from the feedback, the conclusion was that this really is something that should be addressed to PALs. I renamed the draft and presenting it also here now. Next slide. So this is actually all I have. Hopefully this gave you a good introduction. We would appreciate more feedback and input. We have been actively talking from Cisco side to a lot of customers, and we have seen great interest. So we really believe that this is something that is of interest, not only is of interest for everybody, and we would recommend or ask for input and feedback, and potentially adopt the draft and make this a workgroup document so we can progress and make the document complete, and finally an RFC. Last but not least, I think recently there was a discussion about pseudo wires and LDP and S-segment routing, and I was wondering that potentially the signaling draft, which hasn't had too much of progress yet, could be a potential solution to address some of the topics that have been discussed there, and would like to get your feedback on that one. And with that, thank you very much.
Okay, thank you very much, Christian. Do we have any questions for Christian before we move on to the joint meeting? And I'm not seeing any questions. So thank you very much, Christian. And I'm going to move on to 2 weeks slides.
Thank you, Andy. And will you give me the control to flip through?
Yes.
Thank you.
You should have control now.
I see it. Thanks.
Perfect.
So my name is Tariq Saad, and I was delegated to give a report on the MPLS network actions, activities, and a status update on the work that the design team has been engaged with, as well as the working group. So let me proceed. Before I do that, I'm happy to take questions on this, but if it is of nature, the debatable nature or controversial, there is a slot that we left open towards the end of the session. Feel free to bring it up at that time. But if it's a quick status update question, I'm happy to take it. A bit of overview on the M&A Open Design team that was initiated by the MPLS working group. It's currently a joint activity between 3 working groups, MPLS, PALS, and DetNet. The chairs from the 3 working groups coordinate agendas and decisions, and they do meet periodically. The Open Design Team meeting happens every week on Thursday, 11 a.m. Eastern Time. As I mentioned, the chairs are meeting also weekly, and it happens on Tuesday. We have good participation from the working groups, and usually we see around 15 to 20 participants every week. There was a review of documents that were actively produced by the design team and members, and the taxonomy of or the report was left on the wiki. So if people want to check that, we're leaving a link to it. I'm okay to take questions now, or yeah. So I see someone raising their hands. Let me ask Andy: do you want to take questions now, or I'm okay by myself.
Yeah,
So.
if they're quick, absolutely. Jean, why don't you go ahead? Jean Don?
Could it be by mistake?
It could be. Jean Dong, are you there?
Yes, I don't have any question.
Okay, your
Oh.
hand came up
Okay.
on mute. So, okay, so you could drop that hand in.
There.
Okay,
Jean Dog's in
I
the
will proceed then. In terms of updates since last time we met, so this is the third report indeed that we are producing to the working group. The updates this time include some working group documents that got adopted. Let me go through them and review the status of each. So there was the use cases for MPLS network action indicators and MPLS ancillary data. This document got adopted by the working group in May 2022, recently, and the working group and the design team continues to refine existing use cases as well as identifying new use cases and adding them to the document. We have the second document, which tackles the requirements for MPLS network actions and MPLS ancillary data. This document also got adopted in May 2022, and the working group and the design team are regularly refining the requirements in the document. This usually happens either on the email list or during the weekly meeting. Yeah, the numbering changed for some reason. This should be number 3. Oh, 1 second, maybe yeah, number 3. That's what I was expecting. The third document that the design team tackled was the framework for MPLS network actions. And this document got recently adopted. The name still hasn't changed, but we're expecting it to change anytime. But indeed, the working group has decided to adopt this document. During the adoption poll, there were a multiple of points raised, and that incited the chairs to initiate a poll. We will talk a little bit about it on subsequent slides. But we successfully concluded the poll, and the document was adopted on July 13th. As I mentioned, the authors are expected to publish a new revision that includes the name change. So the second update I will go through is the polls that I was talking about that the chairs decided to initiate to tackle some of the comments raised during the M&A framework draft adoption poll. So we tried actually as a design team as well as the working group, we tried to converge on some of the comments raised, how to tackle them during the weekly design team meeting, but unfortunately that did not conclude. So the Open Design Team chairs decided to craft 2 polls and send it to the email list of the MPLS working group in order to see a convergence and move forward. So the polls were left open for almost 3 weeks to gather as many feedback as possible. And subsequently, the chairs decided or concluded and shared the results of the polls. We will go through the results of the consensus call on this slide and the subsequent slide. The first poll that happened was to make sure that the framework is solution independent, which makes sense, but so AD is not, so AD means ancillary data here and not the area director. So we want to make sure that the framework can convey the ancillary data inside the packet in either multiple places, as well as can be signaled in the control plane. An M&A packet may carry the ancillary data in one or both places, including inside the MPLS stack or after the MPLS stack. The conclusion on this, Paul, was to support this position, we had a recommendation for any solution draft such that if they choose the in-stack, they choose the in-stack to carry ancillary data. So ISD stands for in-stack data. If the solution is choosing that, it provides the motivation behind choosing this versus choosing post-stack. So the solution had to include additional motivation for selecting in-stack data. The second poll was a call to converge on whether to repurpose the any existing SPL for M&A action data indicator. For example, an SPL that was thoroughly researched was the entropy label indicator, or whether we should allocate a new SPL for this purpose. So the conclusion on this poll was, the responses showed that we have a strong consensus that we want to allocate a new SPL for M&A and no need to repurpose any existing SPL for this purpose. We also concluded that any other application, other meaning non-M&A application that proposes to repurpose any existing SPL will need to go through the normal working group process if they wish to do so. So we do have a proposal, and we're going to go through that towards the end, the last slide. But this is the conclusion on this poll. In terms of next steps, the open design team that is tackling M&A still is meeting weekly, and they have a lot still to do in terms of defining the solution. We have tackled the base or building blocks and produced multiple documents on that. And the design team chairs thought that it is time now to concentrate or redirect efforts towards the solution definition. So I mentioned there is a review of documents that tackle or that propose different solutions, and we went over that last time, and we met in the design team, and we thought that there is resemblance in terms of some proposals, and the chairs are encouraging authors of such solutions that look alike to collaborate together, and report back in the weekly design team on the progress of alignment. We are expecting a report from the solutions authors to come back post IETF 114. So that will be presented in a meeting that the design team meets on Thursday. So I did mention that there was a call or a poll to conclude on the reuse of a special purpose or repurposing of special purpose labels for different applications other than what it was meant to. So we did agree as a working group as well as a design team that it will not be part of the M&A work. We do have a draft that is proposing the use of entropy label indicator to indicate a slice ID presence and any other and some other actions as well. There were other drafts that highlighted that such reuse is dangerous. I'm leaving both drafts here for people to check. But the conclusion here is that we will leave the working group process to drive the progress on such a proposal. So if we see that we will go through the regular rough consensus to see if such a proposal can progress or not. So this was my last slide on the activities as well as the status update of the design team. I hope I kept honesty here. But if anyone else from the design team wants to add or update any of what I mentioned, feel free.
I don't see any hands being raised, so thank you very much, Tariq. And we're going to move on to Matthew now, who's going to present the requirements draft.
Thanks, Andy.
If you just wait 1 second, let me get your slides up.
And happy for you to advance the slides.
Okay, very good. That's the next question I was going to ask.
So,
okay, very
thank you.
good.
So this is just a short overview of where we are with the requirements for the requirements draft for MPLS network action indicators and ancillary data. And since the last IETF, John Drake has joined the author list and helped us a lot with this draft. So thanks, John. Next slide. So this document captures, or is intended to capture, the key requirements for MPLS network actions that affect forwarding or other processing of the MPLS packets, including requirements on network action substack indicators. So that's referred to as the M&A label, or the special purpose label that's used to indicate a set of network actions. The MPLS network actions themselves, or indicators themselves, and any ancillary data required to perform the indicated action. And this is a product of the MPLS Open Design team. And the requirements are largely driven from a number of proposals for additions to the MPLS label stack to allow decisions about actions based on application data. And just to clarify, these requirements are on protocol design, so they're on the design of the protocols that come out of this work, not on implementations. Next slide. Thank you. So in May, I think we went through an adoption process. There was an individual draft which had reached version 4. And we had around 30 comments which were made on the list and were collated by Loa. And the process we took was to essentially adopt the document wholesale, but add that first new version, add those comments to an Appendix A, which is the working group adoption comments, because there were quite a lot of comments. So you'll see in the draft there's still an appendix containing the comments and some responses to the comments. We published the draft as the working group draft as MPLS MIAD M&A requirement 0, and then subsequently corrected the name to the M&A requirements. That addresses, we hope, the comments in the working group adoption and on the subsequent meeting discussion, and in the subsequent revisions. So we intend to remove Appendix 8 shortly. Next slide. So the main changes, we align the terminology with the framework draft. So essentially what we've done between these two documents is that we have a core set of terminology defined in the requirements draft, and then the framework is kind of a superset of that with any new terminology that's required outside of the requirements to describe things in the framework. We've refocused the draft around network actions instead of indicators for ancillary data. So we removed ancillary data indicator and replaced it with network action indicator. We added a clarification of in-stack versus post-stack requirements. That was as a result of the consensus call that Tarek discussed earlier. So we say we have a requirement that addresses the fact that in-stack ancillary data requires strong justification. We made the distinction between a network action substack indicator, which is the M&A label in the framework, and a network action indicator itself. And this kind of distinction allows the network action indicator and or the ancillary data to be in stack or post stack. We also clarified that solution specs must support or may support user-defined actions. Sorry, may support user-defined actions. And if they do, they must explicitly reserve a user-defined range in their IANA policy for any registry that they define. And we also reorganized the requirements into appropriate sections around the network action substack indicator, the network action indicators, and the ancillary data, and also a set of generic requirements. Next slide. So the structure that's changed since the last IETF is the terminology, which contains new terms needed to define new objects in MPLS, set of generic or general requirements, which is a set of design principles that underline this work, requirements on the network action indicator substack, requirements on the network action indicators, requirements on ancillary data, and the appendix containing the working group adoption comments, which we intend to remove shortly. Next slide. So the next steps. So we've gone through many revisions, several revisions of this draft. We've reviewed them line by line in the MPLS Open Design team. We're now on version 2 of the working group document. As I mentioned, the appendix will be removed in the next revision. We would really appreciate further review and comments posted to the MPLS list or brought up in the MPLS Open Design team meetings. But the authors believe the draft is getting pretty mature now, and we hope that from a quality perspective, it's close to what you would expect from a working group last call document. Thank you.
Okay, thank you very much. Thank you, Matthew. Are there any questions for clarification for Matthew? And I do want to remind people that we have about 40 minutes reserved for open discussion following all the presentations. So if we want to have any extended discussion, we can have it then. And I see that Loa has his hand up. So Loa, go ahead.
A question for Matthew. I didn't really follow what you said about IANA registries for user-defined actions. I think user-defined actions might allocate whatever they want in IANA, and that's not the problem. The problem is that they probably in the standards part of the registry need some code points to be used for the user-defined actions. Isn't that correct?
Yeah, that's what I said. I don't mean that you allocate an individual code point for an individual user-defined action. I mean you reserve a range for user-defined actions.
Okay, thanks.
And Tony is next. Tony, go ahead.
Matthew, when can we expect the next update?
Well, actually, I just posted one on Monday, which is version 2, which is the one I referred to here. I apologize, it just missed the cutoff. So I posted it as soon as it opened again on over the weekend. So
Thank you.
Yeah.
Okay. Well, thank you very much, Matthew. And we're going on next to Jags, who's going to be talking about the M&A header. If you give me 1 second, I will put his slides up.
And
Okay, Jags.
and
Yes, and would you like me to control the slides, or would you rather do it yourself?
could you please control my slides? That'd be awesome.
Okay, I will do it.
Thank you. Yeah. So hi, my name is Jagan Babu Rajamanekam. So I'm going to present present our draft JAGS MPLS MNA header on behalf of our authors listed over here.
Jags, if I can interrupt you just for 1 second, you have a lot of background noise where you are. I don't know if there's anything that you can do about that.
Just a minute. Is it okay now?
Much
Yeah, much
better.
better.
Thank you. Much better.
Okay, thanks. Yeah, can we move to the next slide, please? Okay, so these are the abbreviations I'm using in the slides as well as in the draft. So I just want to put it here so that you can have a quick reference. Next slide, please. Yeah, so as part of this presentation, this is my agenda, which I'm going to discuss today. The first will be the scope of our draft, and then I'm going to discuss on the high-level solution, what we took to achieve the, and then next one is the network action indicator. And then I'm going to discuss on the in-stack network action encoding format, different formats, and the corresponding examples. The next one is the backward compatibility, how we're going to achieve with our solution, and the advantages of our solution. And finally, the next steps, what we're going to do with our draft. Next slide, please. So as a part of the scope, right? So we are providing a solution for in-stack and post-stack M&A encoding format based on the M&A requirements according to the draft mentioned here, aligning with our M&A framework, which is mentioned here. Next slide, please. Okay, as part of the high-level solution, this is a high-level solution which we took to come up with a solution for M&A header encoding. To extend the existing MPLS header for M&A, so we need two main things. The first one is the MPLS network action indicators. So the top level, we want to have a label to indicate the presence of network action substack, and the next one is the a little bit more granular. So we provide as flags to indicate the presence of in-stack and post-stack network actions. The secondly, apart from the network action indicator, we need to encode the network action encoding. So we should come up with a format. So there's a format actually which describes how the in-stack and post-stack network actions are going to be encoded. Next slide, please. Okay, so let's go a deep dive into the network action presence indicator. As I told you, the top level, we have this network action substack indicator. So a new BSPL will be allocated by IANA for this purpose. So this BSPL's TC and TTL field will not be repurposed and then used for any encoding to maintain the backward compatibility. So apart from this, we're going to encode some flags in the next LSC, so which is going to have granular indicators like in-stack network action presence indicator. So this indicates the presence of the in-stack network action that are encoded in the packet, as shown in the figure 1. The in-stack network actions can be two types. Like one is the flag-based that doesn't require any ancillary data. And another one is the network action that requires an ancillary data. So we call it as an opcode based that requires an ancillary data. So the second indicator, the main indicator is the post-stack indicator. So this indicates the presence of the post-stack network actions that are encoded in the packet. So so by using these indicators, we can identify, we can encode both the in-stack and post-stack data simultaneously using the same NASI header. Next slide, please. So as I told you before, the first one is the flag-based in-stack MPLS network action encoding. So this is the network action which doesn't need any ancillary data to process the specific network actions. So here actually there are two parts. One is the in-stack network action header. So these are the flags and some couple of values which would help us to encode the in-stack network actions. So the INI is the field, which is a TTL field, which indicates the presence of the in-stack MPLS network action. And then the IL is the in-stack data length. It's a 3-bit value in the TTL field. This indicates the total length of the in-stack header encoded by the specific NASI indicator. So the length is represented in terms of unit in the unit of word. This does not include the header word. And the last one I want to tell you that is INE. It's an in-stack NA extension indicator. So currently we can encode maximum of 7 additional words apart from the base header. So if you want to extend more than 7 in the future, then this flag would be used to extend the substack as well. So the second part is the flag-based in-stack network action encoding format. So here actually we have flag-based NAI. So this is actually the 19-bit field in the 19-bit label field, and the MSB must be always set to 1 to prevent aliasing from the SPLs. This each and every bit field will be assigned by IANA for a specific application. So if application A wants an flag-based indicator, so then they could request for IANA number and then bit position, and then they could use that. So that's going to dictate what the network action for that has to be done. And there is an E bit which is going to indicate that any one of the flag-based indicator is hop by hop or it's end to end. So if you say any one of the flag is the hop by hop, then hop by hop this E field will be 0. Else actually the E field will be 1. So there's another field is the TC field will be repurposed to use to add additional data length. This is actually 2-bit field in the TTL to indicate the length of the additional word that are encoded to carry the additional flag-based network indicator. For example, currently we can encode 19 offset fields here. So if you say the 20th application is coming and requesting for additional for an flag-based indicator, then the ADL will be set to 1, so that we can add another LSC to encode the flag-based indicator. Next slide, please. So this is the second part of the in-stack network action encoding. So this is actually opcode based. So this is the kind of network action that needs an accelerator to process the network actions. So here the third word is going to describe what is the opcode and ancillary data and some of the informations I'm going to describe now. So in this opcode approach, opcode approach is basically a kind of a TLV format, which is extensively used in many protocols today, and many ASICs are supporting today. So here the NAI opcode is the 8-bit field. This indicates the in-stack network action opcode that should be assigned by the IANA for a specific application. The characteristics of the opcode must be defined while the solution is developed and requested for the value from the IANA. The auxiliary field is 20 bits in total. 12 bits from the label field, and the 8 bits from the TTL field will be used for to encode the auxiliary data corresponding to this opcode. And the ADL is the additional data length. Some of the applications might need to encode more than 20 bits of data in the auxiliary field. So those applications can use this field to extend their encoding of auxiliary data. And the last one is the E bit. So this is actually end-to-end processing bit, the same as the above. So if this specific opcode has to be processed hop by hop, then this field should be set to 0. Else this will be set to 1. Can you please move to the next slide, please? Okay, so now let's see some of the examples, so that you'll have some idea like how this encoding is going to work. So the example one is the pure flag-based MPLS network action, where actually I'm encoding an bit flag position of 1. The application bit position 1 is going to send it wanted network actions to be processed in on the different nodes. So here actually the ADL field will be 0 because we are not adding any additional word apart from the general encoding flags. And in the end, as I told you before, the EBIT is going to be set based on the whether the processing is going to be for this one is end to end or it's hop by hop. Next slide, please. So this is the case, like I have two applications needs to encode their flag-based NAIs. The first application is having the bit position 1, and second application is having the bit position 20, right? So the application 20 cannot encode their bit position in the first flag-based NAI, so they need to use the second word to encode the bit 20. Since actually we're adding one more word to that, the ADL field is going to be set to 1. So this will help us the hardware to identify that the flag-based fields are is going to have additional word, and then it can process easily. So it'll be like a more hardware friendly. Next slide, please. Okay, so this is a third example where actually we are going to encode plain opcode based. We don't have any flag based here. So here in the example, we are encoding the opcode value 10. That is the application which has been assigned opcode value 10 is going to carry its corresponding auxiliary data with it, so that all the nodes can process their network actions correspondingly. Here actually since the application opcode 10 doesn't need auxiliary data more than 20 bits, the ADL field is set to 0. So that indicates that the opcode type 10 has the auxiliary data which is within the 20 bits offset. Next slide, please. The fourth example is the case where the network action needs an data, but which it needs more than 20 bits of data needs to be encoded. So in this case, actually, since it needs more than 20 bit of data, so we need to spill into the next word. So so the ADL, the additional data length value will be set to 1. So this will indicate the hardware that the opcode 12 corresponding informations are lying in the next word as well. So it can take those buffers and then process it correspondingly. So this gives more flexibility in the ASIC to process it in an easy manner. In also in some cases, right, the mid nodes may not implement a specific opcode. So if they don't implement those specific opcodes, then actually they can skip those opcodes and then go to the next opcode, right? So for that, this field could be very well used by the ASICs. So for example, if 12 is not supported by a mid node, so he knows that with the ADL field 1, so it knows that the 2 word is not being used, and then you can skip to the third word and then start processing the next opcode available in the stack. So that's what actually could be very helpful in skipping the unknown opcodes and processing the data. Similarly, E will be set based on the end-to-end processing or hop by hop processing. Next slide, please. Okay, so here actually this is the example where the packet is carrying both flag-based and opcode-based. The flag-based here is carrying the offset 1 for the flag-based, and opcode 10 with the auxiliary data, which is less than or equal to 20 bits has been carried here. That's what you can see here. So since actually it does not crossing their limit, the ADL is 0 for both the cases. Next slide, please. So this is actually like it's a multiple opcode based and flag based informations are carried in this packet. So here, if you see the flag based NAI, we have offset 1 and 4 has been carried, as well as if you see the opcode 10, if you see the opcode based NAIs, we are carrying opcode 10 and 20. And then like when we see the length IL field, right? Since actually like apart from the general header encoding, so we are adding 2 more words. That's the reason the IL equal to 2 is set there. So that will tell the ASIC that like it is encoding this many number of bytes. Next slide, please. Okay, so this is the backward compatibility, like how the solution adopted, and then what we thought about it. So when we introduce this MNA, and then when the header node, the head node needs to encode this MNA into the MPLS stack, then it should depend on the MNA capability. So the control plane needs to inform about this MNA capability of the end node that needs to process the MNA. So in worst case, like if you say like there's some change in the topology, and that's it. In that case, right? So even though the end node is not aware of this MNA capability, since we are using the SPL, this packet, since SPL is not aware, is not able to process by the specific node, the specific packet will be dropped in this case. The second compatibility is like ECMP behavior. For here actually like the labels in the label stack does not change for a flow. So so like like the ECMP is going to be remain same for that specific flow. So we are not disturbing the ECMP flow as such. Third one is like like so in our design we make sure that any of the mid nodes, legacy nodes, like it doesn't interpret our data for an base SPLs which we already defined. The fourth one is the penultimate node with the TTL propagation behavior does not corrupt the MNA stack. That's the reason, like we skipped encoding the information in the top level in the BSPL's TC and TTL field, and then we used the next word to encode the those common flags, encoding flags for the MNA. The last one is since actually like we have opcode based offsets to place our post-stack data wherever we like. So this can coexist with any existing Gash or any other architectures we have. Yeah. Next slide.
Jags, we're well past time, so can you skip to the conclusion?
Yeah, so I'll just quickly show the next slide, and that is my last slide.
Okay, very good.
Yeah.
And it also, 1 second, I see that Greg and Tariq have their hands up. Because we're past time on this talk, I'd like to reserve your comments for the general discussion time, if that's fine. So just keep them in mind and come back then. Thank you. Okay, Jax?
Yeah, sure. So yeah, so this is the main advantage. Obviously, I want to highlight. Like our architecture is more flexible. Since it's opcode based, it can be placed anywhere in the stack. And the next one is the MNA encoding is extensible. Since it's opcode, like we have flags to extend the opcodes even in the future. The fourth point is very important for our case, because this is actually hardware parser friendly. The length field of MNA substack allows to easily skip the substack, as I described before. And the network action opcode, the answer data and the scope and length, right? So the TLV kind of format has been encoded here. So this is easy for the hardware to process the data, and then they can use the existing parser to parse this data. And the next one is that the MSD efficiency. Since actually we encode all this flags, the MSD is efficiently used. The backward compatibility with the existing network, we make sure that it's not disturbed. And the last one is it's ECMP friendly. So even actually, like if anybody wants to encode the data which needs to be changed, even for the same flow, that could happen by changing the information in the TTL field. Yeah, next slide, please. That's my last slide. Yeah, thanks. Thank you very much, and welcome my review comments and feedbacks. There's strong interest from multiple vendors and operators on the solution, and we request MPLS working group adoption. Thank you.
Okay, so thank you very much, Jax. And I'm going to move on to Hayu. Wait 1 second. Let me get Hayu's slides. Okay, Hayu.
Okay, be clear.
Yep, we can hear you great. Would you like me to move the slides, or would you rather do it yourself?
Yeah, maybe you can.
You have
Okay.
to do it, Andy.
Okay, I'll take care of it. Thanks.
Yeah, it turns out I'm the first on-site presenter. Good to see everybody again. Today I'm going to give you a quick review about update of our MPLS extension header draft. Next slide, please. Yeah, we published the initial version in 2018, and since then it has been evolved to version 07 today. It's based on the numerous discussions in the open design team. And now the title is changed to MPLS post-stack extension header to reflect our focus on in this draft is only on how we encode the MPLS network actions after the label stack. And also, in this new version, we align the terms with what's defined, specified in the M&A requirements and the framework documents. And we also add several new authors. Next slide. Yeah, first a quick recap about what the MPLS extension header is about. Obviously, we will need some indicators in the label stack to tell us we have extension headers after the label stack, but how it's defined is out of scope of this document. In this document, we only specify how the extension header itself is encoded after the label stack. As you can see in this figure, after the label stack, we will first have a header of extension header, which is basically a summary of what follows. It tells you how many extension headers you will have, what's the total length of them. And it also provides the information about the original high upper layer protocol type. So this will be useful to tell you what's the original protocol layer 4 protocols in the packet. And also it tells you what's the next headers type. And after this summary, you will see a set of standard containers. Each of them is an extension header, which will contain a specific network action. And each container has a standard, starting with a standard words, tell you the next headers type and the current headers length. This is very similar to IPv6 extension header, if you are familiar with that. So with this arrangement, we will support up to 15 extension headers in a single packet. And then if based on the length arrangement, we can support the maximum length of all the extension headers can be up to 1 KB in a single packet. And we do allow you only have this header of extension header, but followed by 0 extension headers. So this can be used to indicate the type of upper layer protocol, and also it supports the potential use of add and remove extension headers on the path. Next slide, please. So we define several new next header types in this document. First, we want to share the code point with IP protocol numbers, which means we will need to apply new protocol numbers from the same registry. And the new type defined in this document is the first one is a none, which means no next extension header and the payload after this extension header. This is the last one. So this can be used for special packages such as a probing package. The second type is unknown, which means this can only be used in last extension header, which basically tell you, okay, what's the payload type is, we don't know. This is compatible with the current practice in IPS. And the next type is MPLS, means another MPLS label stack follows this current extension header. This is very useful for the hierarchical use cases in which you have a multi-level of MPLS label stack. All the extension headers can be skipped in one step because we know the overall size of the extension headers. So it allows us to quickly access the original upper layer protocol. And also, we explicitly support two types of extension headers, end-to-end type and hop-by-hop type. And we require the end-to-end type extension headers must be located before the below the hop-by-hop, because hop-by-hop need to be processed every hop. So you have to put HBH type first, and followed by, and then after that you will have the end-to-end type. So this can help us to optimize the performance. And you can see each extension header is just a standard container, and it allows to freely define newer applications in the future to put it in the extension header. Next slide, please. And we have several other companion documents with this one. The first one is actually a summary of a possible method for the extension header indicator. But we don't want to progress this document further. We will retire it once a standard method is chosen by the working group. But you can take a look at that, and it basically covers every possibilities we have discussed up to now. And the second document is called MPLS Extension Header Architecture. This is notes network action architecture. It's actually about the network, the network architecture to operate this MPLS extension header. For example, it describes several terms like the extension header path. What's its relationship with the label switching path? And we will have extension header capable and incapable nodes, and how we will announce such capabilities in the network. Such concept is actually common also to the in-stack network action. And therefore, it's possible to involve this document for the MNA network architecture, because we think the concepts covered in this document is very useful there. The last companion document is about MPLS extension header label stack operations. It's a kind of performance optimization document. Basically, since the action itself can be deeply embedded in the package, then if we can, based on the top label, we can tell there is some actions in the package that will be useful, help the node to decide if we want to examine the label stack further or not. So the idea of that, you can use some extension header forward equivalent class label, effect label, to indicate that if one node actually figure out there are some there is such action labels or not in the packet. So similarly, this concept is also applicable to the in-stack network action. So it's possible to evolve it to be a generic method for MPLS network action as well. Next slide. So this document is already pretty mature after many different revisions. So therefore, we also request the working group to adopt this as a solution for supporting post-stack network actions in MPLS. And well, also we will next step. The key work is to determine actually what's the extension header indicator scheme. We need to make it coherent with also the indicator for in-stack network actions. And also as the next step work, we will expand the scope of the other extension header companion document to make it suitable for the M&A work. Thank you.
Okay, thank you very much. Greg Mirsky has his hand up. So, Greg, what's your question?
Greg Mirsky Erickson. So I'm a little bit confused with the order of your next steps, because it appears that you are proposing adopting this document as a partial solution to M&A requirements.
Yes.
But it seems that as is, this document does not address all M&A requirement documents which are adopted by the working group.
Yeah, this document is about the post-stack encoding, and I think this independent part, which can be developed in parallel with the in-stack, with the indicator and also the in-stack action.
I think it will be more helpful to discuss the solution that addresses all requirements that adopted by the working group, not a partial solution. Thank you.
Okay. Thank you very much, Hayu. And we're going to now move on to Karidi. And Karidi is going to be our last set of formal slides. And following Karidi, we will have time for open discussion. Let me just load Karidi's slides here. Okay, and Karidi, would you like me to move the slides for you?
Yes, please.
Okay, very good. And if you'd stand close to the mic.
So
Do a mic check?
look better? Yeah?
Yes.
Right?
Okay, thank you.
Okay. Yeah, thanks. So if you just stop on this slide, I'm presenting. I did make a big mistake of not adding Tony's name to the author list. He did help a lot, so mea culpa. Next slide, please. So yeah, as I mentioned, Tony did help restructure this and took part in a lot of discussions, both internally as well as in the open design team. And he is fairly active there. He's co-author on several drafts there. Next. So as I said, we've had many discussions on this draft within Juniper, between us and folks in Broadcom. We made a few pretty big changes in this last revision that we think will really help make this easier to implement on both our own chips as well as on Broadcom. So the big change is to replace continuation bits with length fields, and I'll get into that in a second. But the upshot of this is we're fairly confident that this can be implemented efficiently, and in fact, that's where we'll go next. Next slide.
So the big change that we have, we used to have these things called continuation fields or continuation bits. And essentially, a continuation bit would tell you when a particular block ends. So the whole FAI block at some point has to end. So if the FAI, and I'm going to call it FAI for now, but we should probably change the terminology. So if the special purpose label saying that there's forwarding actions here comes to the top of the stack, you want to remove the whole block. So to know where the block goes, we were using continuation bits. But feedback from the Broadcom folks said that it's much easier to have a length field up front, and then you say, oh, this whole block is 10 words, just take the 10 words and throw them out. So we moved from having continuation bits for the whole FAI block for the standard in-stack data and for the user in-stack data, user-defined in-stack data. So we moved everything to length fields. There's not a huge difference in terms of overall number of bits needed to encode all this, but the length fields allow for much easier processing. So that's one big change that we made. Next slide. Also, from the point of view of the draft itself, there have been a lot of improvements in readability. And so, for example, separating the description of the label stack entry, which has all the flags, but the flag definitions are in a different section, so it reads better. So those are the two big changes between the previous version and this version. At this point, we're just twiddling bits. So we think that we're really close in terms of a technical solution. Next slide. So we think that the draft is ready for working group adoption. We've been discussing this for over a year at this point. Internally, we've done a lot of fine-tuning, and so we think it's ready. In addition, we'd like to start doing some prototypes of this, both on our chips and also, hopefully the Broadcom folks will do some on their chips. And each of us has multiple types of chips. So we can get a sense of how it is, how easy or how hard it is to implement this on a variety of chip types. To do that, it would be nice to have an early allocation of a BSPL for FAI. So I don't know how these, I don't know how to draw a dependency diagram between the three requests here, but we'll let the working group chairs work that out. Questions? Do I hear someone say ship it? No questions. All right, thank you.
Great,
Okay, thank you very much.
I have a
yes.
question or two.
Okay.
Hi, Kiran.
Yep. Go for it. Okay. Sure.
Probably not changing anything technologically. It's just an update. So you get to the point where it's easy to read the document side by side.
Okay, I agree.
And then when I look at this document, I find it fairly complete on ISD, but it's much weaker on PSD. Do you agree on that? Or is it intended?
So could you repeat that? It's fairly complete on ISD?
The ISD, yeah.
Yes.
Yeah, you get pretty good treatment of ISD. Well, you don't agree on everything, but I understand what you're saying.
Yeah,
but I think there are missing parts on the PSD side.
Agreed. So that was actually the intention. This draft primarily focused on the ISD part, and it points to Jeffrey's document, and I think Jeffrey and how you have combined. So it's sort of like you have an ISD document, this is the ISD document, And then you have another document that's the PSC document, and that's the one that how you and Jeffrey are writing. So yeah, that is the intention.
I think that's fine, but I also think you need to say it.
Okay.
Pointers,
Okay.
pointers, pointers, pointers. Probably
Sure.
all of those documents need to point to each other.
Okay. No, that makes sense. We'll do that.
Okay, thanks.
So align the terminology, put pointers for PSD. Okay, got it.
Yeah.
And Tariq is next in the queue. Tariq, go ahead.
Thank you, Kiriti. I'm a co-author, but I can't help that there are some resemblance in terms of handling in-stack actions in this solution, as well as in the solution that Jax presented earlier. So my question now, as a open design team co-chair, there is we're trying to incite alignment between the different solutions. So are there plans to see if you can converge with the other solution?
I have to discuss with my co-authors, but I think while the intent of the drafts is similar in that they want to encode multiple actions and include data with the actions, the formats are very different. So at this point, what I would like to do is to implement what we have here and get some feedback from what does it actually take to implement this on different kinds of hardware. And yeah, and then if my co-authors say, there is some scope for alignment, I'm happy to think about it, but right now, that's not where my focus is. But it's a good question.
Okay, and Loa has his hand back up.
So correct, when you said implement, are you meaning some type of alpha implementation for test or something, or are you actually going for full product code?
More like alpha, more internal implementation in our lab. Yeah.
So that I'm not saying we should do it, but actually, if we decide to do it for one of the solutions, we probably should sponsor it for all of them and then make comparisons.
Yeah, I don't have cycles for all that. I hope I have cycles to do this one.
I know, but maybe talk to Remy.
Yeah, so if others want to implement theirs, and then we can have some standards, or not standards, but some metrics by which we compare solutions, that would be, I think, very helpful. But from our point of view, we just want to see, did we specify this well? For example, continuation bits versus sizes, which works out better? How does the hardware respond to all this? How many cycles does it take? So we have our hands full just doing ours because we're going to try to do it on 4 different types of chips. Question from How You?
Okay.
How you go ahead?
Yeah, this is not a question, but just a comment. I think it's a very good idea to actually compare the different solution proposals from the different perspective, like the overhead, the performance. But in this sense, in this design, I think performance is very critical. So we have to do it carefully. And on one side, we can ask more ASIC experts to join the work to evaluate the scheme. And meanwhile, we can also do some kind of software-based evaluation. As it also can be do very quick and give us a sense of what's the performance actually what's the most influence part of the performance.
Yeah. So you have a good point, but we're going to take it in steps. So the first thing is the proposal that we have implementable reasonably? The second step is, here's our proposal, here's the metrics from our proposal. If someone else were to do a different proposal, then we agree on the metrics, then we can compare them. But we want to start with something, right? So we'll start with this proposal. But you're right. Eventually, we can get there and say, here's some common metrics, and let's compare different implementations.
Yeah, so basically there are several different type of design ideas. One is using the catalog followed by the action itself, and just use a conventional chain leg structure.
Right.
And some other even combine the two together. So I think there's a great implication on the performance issue. So it's a very critical to access it.
But crawl, walk, run, right? So we want to crawl, and then we'll walk, and then we can maybe run.
Right.
Yeah, thank you.
Okay, and Wim is next in the queue.
It's not necessarily a question to Kiriti, but it's more of a working group question. It's like, I think for PSD, we somehow are converging somehow as in a single document with what Boo is presenting, right? I have the feeling for ISD, we have two probably competing solutions. I have the feeling that you want to continue with your thing. From what I was trying to get to as more as a working group question is, I'm hoping to converge to one solution because this is data plane, and I think we should try to converge to one thing. So my question is more, first of all, is that aligned within the working group as an objective? Because if you focus on your thing and someone else focus on his thing, then we have like how do we converge on getting towards a single most optimal solution to implement, which works on, I would say, most hardware?
Yeah, so from my point of view, I just want to know if this particular approach works and is sufficient and so on. And so, independent of IETF, we want to do the implementation and take back learnings and then bring it back to the draft and so on. The convergence point is really important, and that's a working group thing.
Yeah.
And so it would help if, for example, the alternative solution did a similar thing, and then we could compare them, across some metrics. I don't know what the metrics would be, like number of cycles it takes or something. But you want to do something that's independent of hardware, but meaningful from the point of view of forwarding. And then we can make, I think, more rational decisions about should we go forward with this or with that, or are there ways to converge them? Because ultimately, yes, for a data plane solution, we don't want to.
Yeah, the question is mainly how do we do that somehow?
Yeah.
All right, thanks.
That's why the working group chairs get the big bucks.
Yeah.
Okay, Loa is next in the queue. Loa, go ahead.
Yeah, I can't answer what the working groups take on this is just now. We need to discuss it a bit, but I'm pretty much on the same page as Wim is. We should take decisions that relates to the standard based on how we best actually reach to a implementable and compatible solution. So I don't think there is any kind of differences about that. I can understand that some companies want to go ahead and try to test their own solution in their own environment, but eventually they have to come out and actually participate in the what the IETF or the MPLS working group are doing.
Yes, of course. And like I said, we had a lot of internal discussions, and some of the decisions that we made, we want to validate that did we take the right answer to it. And so, I mean, this will be valuable feedback to the working group as well as to ourselves and our implementation. So it's also been a while since we started this work. So, we want to just move forward. But we will bring back things to the working group, implementation reports. Again, if we can agree on some metrics, We can say where we score on those, and that would be sort of the idea.
Okay, and Tarek, you're up.
On the same topic, and again, as a co-chair, I totally understand where you're coming from, Kriti, and there might be valid reasons for diverging. The only thing I'm going to highlight is we owe the design team as well as the working group a report of the reasons why we cannot converge, and I understand your stand.
Yeah, so I don't even want to jump to that. I want to start with a report of how this particular implementation worked out and what we learned from it. And then we can talk about where converge. I mean, they can happen in parallel, but I think doing the implementation would shed a lot of light. But I think in parallel, we should discuss, are there points at which we can converge? Are there points that are pretty incompatible? What would the shape of the final solution look like? Again, I'd have to discuss with my co-authors, but I'm open to those.
Okay, and you have to get into the queue if you want to speak.
Yeah, I am having trouble dialing into the Meetico. That's why.
Oh, okay, go ahead.
If you allow me.
Yeah, please.
Thank you.
Identify yourself in that case.
What has been done in past in situation, is Zafar Ali. What has been done in past in cases like this, like we mentioned, this is data plane. So we have to be extremely careful in moving forward with the solution, is to define metric that can compare solutions, that can give feedback to the working group in terms of what solution works better, what works, what doesn't work. And that has been an approach that's been taken many times by many working groups in making decisions like this.
So you probably missed it when I said we wanted to find metrics, but that's okay.
Yeah. So I think, we do want to find metrics to compare the solution and move forward. Yeah. Thank you.
Kriti,
All right. Thank you, Andy.
Kriti, before you sit down, I wanted to point out that you still have 3 slides in your deck.
Okay. There's the NFFR.
Yes, exactly.
Okay. Sorry. Next slide, please. This is going to be quick. The NFFRR draft was a standalone draft saying, I want a new code point, a new special purpose label. We've changed it and said we just want a bit or whatever it turns out to be an action in the M&A document. So we've gone from asking for a base special purpose label to an action base so that we can actually tell a router, please don't do further fast reroutes. And the second part, so if you go to the next slide. So in the beginning, we had a lot of discussion. We've incorporated all the feedback. We got bogged down with this whole, base special purpose label and whether we have our own standalone or whether we incorporate it into something else. So this is no longer an issue. Next slide. So as we do, so the problem is acknowledged. People basically say we need to move forward with this, or it's a useful thing to move forward with. No other alternatives have been proposed. There were some feedback. We incorporated that. So we think this is ready for working group adoption, and we will consider this as part of the prototype for the previous document. So when we prototype the FAI document, one of the things there is a no further fast readout bit, and we will implement that. Ketan?
Okay. There's a question from Ketan.
Yeah, hi, Ketan Talaulikar, Arcus. About this problem acknowledge and solution acceptable, I think there are control plane based solutions, at least for some of the use cases. which I have started a mail thread, and maybe we can discuss further. So I believe we should discuss that and probably also consult BESS, where the EVPN work is happening. There's a control plane solution there, and maybe same for perhaps Spring. At least those are the two that I'm aware of. And yeah, maybe we can continue on the thread.
We can definitely follow on the mailing list. Wen, who is a co-author, also has a comment. I mean, the goal here was a data plane solution, but Wen, if you have a comment, please.
How you?
So Wen is going to respond as a co-author, but yeah, how you can comment.
Yeah, hi, this is Wen from Juniper. I aware recently, last 2 IETF ago, there was another proposal for address this solution. When this draft was first published, we mentioned in the talk why this solution we feel it's better because it's more scalable. From EVPN perspective, there's a different type of service, and this solution will apply to different type of service. VLAN aware bundle service, especially in particular if you have a 4K VLAN. So this solution, just one label, will address all those issues for the looping in the FRR case. In addition, the same solution also apply for layer 3 VPN or other use cases. We feel just one solution not only apply to different type of EVPN service and also to different other type of service. So that's really the benefit for this solution. It's simple and that's it. Yeah, thank you.
Yeah.
So Ketan,
Yeah,
we probably owe you a response on the mailing list, but what she said.
Yeah, I understood what was said, and I think it's best we discuss this. And I would suggest maybe including the BESS working group, perhaps, because it's I'm not saying that the BESS the individual draft is let's say all complete and all good and ready. Perhaps it can be improved. So yeah, we can continue the discussion.
Okay.
Thank you.
Okay.
Yeah, okay. I think this is a interesting use case because it has some unique features we need to consider in our M&A discussion. Because in my understanding, this action is actually applied on the inserted on the falling MPLS label switching paths. It's not starting from the edge. So if you allow such kind of actions, it implies in our requirement we do allow to insert or remove some certain actions on the falling paths. So my personal opinion is we should allow such kind of behavior. This will make this M&A more flexible, but I don't think it's currently reflected in the requirement or architecture documents. So we should discuss that further.
Okay.
Okay, any other discussion of Kuwaiti's drafts? Yes, Craig, go ahead.
Hi, Greg Muskie-Erickson. I just want to remind that no FRR is a part of the use cases document adopted by the working group. Thank you.
Thank you.
Okay, I saw your name flash for a moment, and then go down. So I think you're probably okay. Okay, very good. So I think we're all set, Kuwaiti. Thank you very much.
Thank you.
Now from this point on, let me close Kuwaiti's slide and turn my own camera on. Okay, great. So from this point on, we have open discussion time. So if there's anything that anyone would like to bring up regarding anything that's been discussed or anything else that's going on with the open design team, now is your chance. either remotely or in the room. I would like to remind you, if you're in the room, don't just walk up to the mic. Please use the tool to get into the queue so we can manage it correctly. Tariq, you're next.
Tariq Saad, and my question was to Jagan. I don't know if the plan was to bring back slides, but I don't need that. They presented INI and INE to indicate actions in the stack and post the stack. My question is about the order of invocation of actions. Are we dictating that in-stack actions should be before post-stack actions, as well as within in-stack? How is the order dictated, or is it not dependent on the order? What's your thought on that?
Jags, can you answer that, please?
Oh, yeah. Could you guys hear me?
Yes, absolutely.
Yep.
Okay. So you're asking, I'll just repeat the question so that I understood your question. So we have INI and PNI. So you're asking that INI is for the in-stack indicator and PNI is for the post-stack indicator. So you're asking like which one, whether in-stack or post-stack is going to be the first?
Yeah, if there are multiple actions, some in the stack, some post the stack, how is the order dictated? Yeah, that's it.
Okay, so the order actually like in the order like what we encode. That's why you said it's a more flexible. Like the application opcode 10 and application 20, right? So the 20 can come first and 10 can come second. So it's more flexible. Like it's whatever the hidden things that the order should be, it can encode that way in the in-stack data wise, right? So in-stack wise is post-stack data. So that actually like we haven't covered it. Probably we can talk to Huawei. Who are you? So who is our post-stack encoding partner? So we can discuss with them and then we can come up with that.
Okay, thank you. Looking forward to the resolution. Sure.
Sure.
Okay, Greg, you're next. Greg, go ahead.
Greg.
Greg Mirsky, Ericsson. So my question to Kirili. So am I understanding correct that you intend to cooperate with HARU for the post-stack data encoding?
That's me.
Yeah.
Yes, indeed. So the idea would be, I mean, our implementation will focus on the in-stack piece. And, I have a bit here, and can I parse it, and can I get the associated data, not for NFFRR, but maybe for the slice ID and so on. But there will be a bit that says there is post-stack data. And then we'll see what it takes to implement, to reach the post-stack data. But the post-stack data format will be what's defined by HARU and Jeffrey. So I think we can keep them relatively apart, but at some point we'll see if we can bring them together.
Okay, so that means that you support the idea that encoding of in-stack data and post-stack data will be different, using different encoding.
Yeah. Yeah.
Okay, interesting. Thanks.
So the in-stack data, you're working with 32 bits, 31 bits, and so you probably apply different techniques and try to do things in a much more compressed way. You might say, I don't want to have a length field that's all implicitly either it's 0 or 4 bytes. Whereas in post-stack data, I think you have more space, you're not constrained, so you don't have to work in the same format. That's at least my thinking now.
Okay, let's see and discuss it. Thank you.
Okay, Zhidong is next. Zhi? Shi,
you hear
are you
me?
there? Yes, we can hear you.
Okay. So my first comment is about the post-stack data. I think according to the previous poll result, it shows that the PSD is a necessary component of the M&A framework and the solution. And from today's discussion, it is clear that we are converging on the single solution for the PSD encoding. So that maybe it is a good thing to move forward the post-stack data encoding first. The second thing is about the ISD. According to the poll, again, we think that it shows that people agree that ISD may be used. Well, there's also some concerns about to suggest to minimize the use of the ISD. So it seems that it would be better to define ISD as an optional component so that we can allow a mechanism to carry the indicator plus the PSD only. And second thing is if we want to minimize the use of ISD, it seems the length of the ISD should be constrained and the format should be easy to parse. Because we have seen the proposals to carry the ISD multiple times in the label stack. Also, the third thing is we may need to consider the possible changes to the label stack operation introduced by the ISD. So these are some concerns about the ISD design. And following these considerations, we have just submitted a new draft on the M&A encapsulation this week. I will post it to the chat. Okay, thanks.
Okay, thanks. Loa?
I have something I haven't talked about before, but it was brought up discussing order among actions here. So a small comment. Do we actually think that if you look at PSD, for example, we can actually take them in the order they are specified, and then just go through the entire chain? Or is it like, depending on which actions we have, the order could be different? I don't know if I'm clear, but what I fear is that the order between, if we define 5 different actions, so we do 1 first, and then we skip 2, do 3, and skip to 5. But if we actually decide to do number 4, it might be necessary to actually do that in that chain before number 3. So how do we handle this? Now I confused everyone.
Tarek, you're next.
My question now is on terminology of the framework draft, but coincidentally, it's related to what Loa is asking. There is a term we introduced in the framework is network action substack. It gives the illusion it's a stack and there is an order of how we push to the stack and then pop. Or if we want to do popping, I'm not sure if we are going to allow popping of an action from the substack. So that would be one thing to clarify. And the stack is, it has an order in nature, like a nature of a stack. It's like there's an order of who pushed first and where that entry sits. So would that, place in the order of the stack be the order of invocation of the action?
Okay. Tony, you're next.
No, I have a comment.
Okay. Go ahead, Loa.
Tarek, that means that you can only do that for a homogeneous set of actions, either PSD or ISD. You can't mix them.
At least if we can clarify within ISD, because the framework draft talks about substack or network action substack.
Yep.
Okay.
So a solution has basically a solution has to define what the order of operations for the network actions are. Now that could be anything deterministic. You can go according to code point numbers. You could go top to bottom, left to right. You could go right to left, bottom to top. Whatever you want to do, as long as it's deterministic. And of course, it has to be specified in the solution document.
And you could do create your own list and do it that way.
You could do that too. It just needs to be specified.
So could there be, in that list, could that be a mix of PSD and ISD related action indicators?
It can be anything as long as it's documented.
Okay, you told me.
Okay. How you go ahead?
Okay. Yeah, I think for PSD, the only requirement we suggest is to put the hop-by-hop type before the end-to-end type, because on the pass node, you will never need to look beyond the hop-by-hop extension headers. So that's the obvious optimization. Other than that, I don't think we should dictate any order of execution, because that's totally depend how you implement that. In many platforms, I know that actually they do the header pass up front, and then in the actual for a processing pipeline, they decide which one to actually execute first, with the order of execution. So in that sense, we shouldn't dictate the order of the actions. That's my comments.
Okay, thank you. John, you're up next. John Drake.
I'm going to say, following up on what Tony said, it's also possible to define a composite network action, which is a set of individual network actions in a specific order.
Okay, that was quick. Gian. Gian Mishra?
Yes. Yeah, I'm here in person.
Okay, very good. Go ahead.
I had a quick question. If there's a case where you had both in-stack and post-stack, I guess in parallel, would there be any performance issues with, and probably order of operations, kind of what we're talking about with the M&A actions of, processing post-stack first and then in-stack, or maybe not doing both in parallel? Because that seems like there may be performance issues related to that. Thank you.
Was that question aimed at anybody in particular?
It was for anybody who can answer. Just a question that I thought of how would that work, and would there be an order of operations if you're processing post-stack and then you also had in-stack data first? Would you want to process in-stack first before post-stack, or vice versa? To me, it seems like you would probably want to do the top of the stack in-stack first and then post-stack, but that just as regarding performance, I guess, and what would be the best way to do that as far as performance?
Kwede, would you like to answer that? I see you standing there.
Sure.
Yes. So the idea of in-stack data is it should be the stuff that is more critical, and because it's more critical, you want to put it closer to the top of stack, cause a lower penalty or impose a lower penalty on getting to it and doing things. So there's this implicit thing that anything that you put in stack is more urgent. And then the post-stack stuff also has the additional thing that there will be some things that are hop by hop and some things that are end-to-end. So post-stack, you would never put something that's in stack, which is end-to-end. That would be a waste of in-stack space. So that's kind of the answer to your question, Jan, that in-stack data will generally be more urgent and stuff you want to do first. Post-stack data will be generally stuff that is more optional, and some of it will definitely be pushed only for end. So it's not hop by hop, it's end to end. That's my view.
Great, thank you. Now we have 5 minutes left in the session, and MeetEcho is pretty strict about meetings ending on time. So I've locked the queue with 2 people left, Rakesh and then Hayu. So Rakesh, go ahead.
Hi, Rakesh Gandhi from Cisco Systems. So just to answer that question on the order in which the network action to be executed, Jackstrap has a very good solution for it, which is opcode based. And the NCAP node can add the opcodes in a certain order. It can be 21st and 10 or whatever order that NCAP node desires the midpoint to perform the action. That's one good feature about it. The second thing is that an opcode itself can be defined as a series of flags, and it has a meaning that it needs to be executed in this order. So that also allows us to do the operations at midpoint without any ambiguity in a certain order. So there is a lot of flexibility in that draft to help with this situation. Thanks.
Okay, and Hayu?
Yeah, I don't think the urgency is a criteria to put it in stack or post stack, because obviously some actions will require a large header overhead. You simply cannot put it in stack because the size is too big to put in the stack. You have to put it post stack. So, but it might be very important for that action. So, and also from the hardware design perspective, if you do the parsing first and do the processing later, actually it really doesn't matter if we put earlier in the packet or later in the packet. So it's totally up to the implementer to decide which action you will execute first. So the urgency is not a criteria here.
Okay, thank you. And Tarek, can you close us out?
Sorry, I didn't realize if the queue was closed or not. Was it closed after me or before me?
It's closed now.
Okay, thank
so
you.
You'll last.
Okay. Okay. I was going to ask a question. Oh my goodness. I forgot the question. I'm sorry. I'll back out.
You can take it to the list, please. Okay, and with that, I would like to close today's PALS, MPLS, and DETNet joint session. I'd like to thank everyone who participated, both remote and in person, and we will see you all at IETF 115. Thank you very much.
Do you have a note taker?